Hello again, everyone. So today I'm going to finish this set of slides uh, labeled Lecture 6, Inheritance and Polymorphism. So there's a couple of very simple topics that I want to take care of today. So the first one is this instance of operator. Instance of. Now, usually operators are the plus sign, the minus sign, divide, multiply, to assign a value to a variable, we use the equal sign. That's also an operator, of course, and an assignment. That's the assignment operator. Um, this one's slightly strange because it's not just a single character like we have been used to, but instead the instance of operator is actually exactly what you can see over here. It's this, this, these two words put together, instance of. And we can this is used as basically to check whether a certain object belongs or is of a certain type of class, certain class. So what I'm going to do is I'm going to do a quick example that's slightly different from the one in the slides, which is good because now you can try out the example in the slides yourself. And I'm going to go over here. So I already have this project 11.4 for today. Um, and what I did is I imported the employee, faculty, and person classes from week 10.1. And not only that, I commented out everything that they were printing out in the constructor. So right now, faculty. So at the very top is person. Person has nothing in it. Right now it has only a constructor which does nothing, only a no-arg constructor. And a subclass of person is employee, extends person, as you can see. And I just commented out what was in those constructors. So we just have actually, I can just delete, um, could delete this one as well, that's fine. And then we had the faculty class, which is a subclass of employee. Okay, so person is a superclass of employee, and employee is a superclass of faculty. Okay, right. Oops. Okay, so go back here. Oh, not faculty. There you go. All right. Um, so what I want to do is I want to try out this instance of operator and show you how to use that. Okay. So let me begin by this was just to show you that I took these three classes from week 10.1. You can make them again. There's nothing in them after all. I'm going to save that time. And I'm going to make three objects. An object person, P. I'm just going to call the no-arg constructor for that. Um, then employee. Call the no-arg constructor for that as well. And finally, faculty. Okay, so now I have three objects, a person object P, an employee object E, and a faculty object F. And what I want to do is I want to try out yeah, so let me print this out. So system.out, system.out, print line, and I'm going to print out the result of checking. Oh yeah, actually let's make this a little nicer. So if, and in the if condition I check if, let's say I want to compare P instance of, I want to check if P is is an instance of class person. Obviously it is. can see that from up here. And if it is, then I'm going to print out a nice message that says um, P is an instance of class person. And if it's not, else, I'm going to print out a message that says that P is not an instance of class person. There you go. We try and run these. And there you go. So P is an instance of class person. So this this if condition over here was true. P is an instance of person, and that's why we went into this line over here. And I can do the same thing now with, I could also compare. So if P is an instance of person, then I guess if we check if P is an instance of employee, the answer what should the answer be? Remember, employee is a subclass of person. So person is the superclass. So P, the object P, is an object of class person, which means it's not. The answer should be, the answer to P instance of employee should be false, which means the second line in the else condition should print out. There you go. P is not an instance of class employee. There you go. And guess what? We can do the same thing for the faculty class. We can compare and check if P is an instance of faculty, and we expect the answer to be false, which means we'll go into the else condition, and this will print out P is not an instance of class faculty. Try this again. There you go. Okay, so P is an instance of person, P is not an instance of employee, and it's not an instance of faculty. Now, instead of, there's a lot of code, I could actually do something here. I could, if I want to use this, if I want to do this comparison of an object with these, against these three classes, would actually be handy if, let me just close the main method up here and instead put all of this, let's make that static, public static void. Let me put this into a method called checkObject. And now I'm going to take advantage of polymorphism, and I'm willing to accept any object of any class, because I'm saying anything object or derived from or subclass of object is acceptable. And inside this method, I'm going to have to make some changes. I'll call this obj. I'm going to check if this object is, if it is a person, employee, or faculty. I'm going to check all three. Now, okay, and so in the main method, I would just call check object. I can pass it anything here. I'm passing it P, and we'll see the output. So now it's called, it's passed as an object. I just give it, I just put in a generic name obj. Object is an instance of class person. Object is not an instance of class employee. And object is not an instance of class faculty. Just what we had, exactly the same we had before. But now that I have this whole thing in a method, what I can do is I can now easily do the same thing for employee E and faculty F objects. Notice the output does not look very nice. It's all squished together. So what I'll do is the last line that prints out, I'm just going to add a new line character. Run that again. There you go. So the first output is when I pass it the P object, which is a person, and the answer is so obj is an instance of class person, but it's not an employee and not faculty. And the second time I call check object, I pass it E, which is an object of class employee. And check this out. Object is an instance of person and is an instance of employee. So employee is a subclass of person, and that's why employee is an instance of employee, sure, but it's also an instance of person because every employee object, because employee is just a special type, a subclass of person. So that's why the object E that I'm passing to check object over here, when I call instance of person on it, the answer is true. And guess what? When I do the same thing with faculty, faculty is a subclass of employee, and employee is a subclass of person, which means every faculty object is also an employee and is also a person. And there you go. Obj is an instance of class person, of class employee, and of class faculty. All three. Now I realize it's not very readable, so if you want to make it a little readable, something you can do. So you can just say obj toString, call the toString method instead. And we know that this will put in substitute package and class name of the object, which would make more sense. Okay. Now if we run this now, so this is our package, project 11.4 package. So the first time we passed it a person object. Person object is an instance of person. It's not an instance of employee, not an instance of faculty. The second time we passed it an employee object. Employee is an instance of person, is an instance of employee, but is not an instance of faculty. And the third time we call check object, we pass it a faculty object F, and for faculty is an instance of person, is an instance of employee, and is also an instance of faculty, of course. So that's the use, that's the purpose. That's what you can do with the instance of operator, and as you can see, it's a little unusual compared to the operators we've been using so far, in the sense that you have to type instance of like this. Make sure you don't make a typo. If you type it right in NetBeans, at least, instance of will be highlighted in blue because it's a reserved term in Java. Okay, so got that. Jump back here. So we did instance of, and related to instance of, we have a method called equals. And what the equals method does is it checks whether the contents, the data contents, the member variables of two objects, whether they have the same values or not. So in the example we have over here, our person, employee, and faculty objects were all empty. Let me change that. So let me go into the superclass. Let me add a string called name over here, and let me add a constructor over here, one that takes string as argument, and inside it sets this dot name equal to name. assigns the name to the member variable name. Okay, and let me go back into the main method, and let me very quickly, in addition to what we did over here, let me create person P1, give it a name in the constructor, and create a person P2. Give this the name Hassan. Select here, you can see, no problem. And right down here, I am going to print out system.out.println. I'm going to print out the result of calling the equals method. So p1 dot equals p2. This should work. And the answer is false. P1 does not equal P2. They have different data members. But now let me go up here and let me just add a third one. Let me add a third person. P3. Give this one the name Usman as well. And let me add another comparison. So now let me check if P1 equals P3. And we expect the answer to be true. Oops. P1 equals P3. So, still false. The reason for that is the equals method is inherited from the object class. So just like the toString method, we inherit the equals method from up high. And this is what's inside the object class's equals method. So it's a public method, returns a true or false, Boolean, called equals, and for object it accepts really anything. And inside it, it just checks if it has a single line. Now for us, as we just saw, this one line does not work. In order for it to function the way I described it, we have to make some changes. We actually have to override it, just like we override the toString method. So let's say we want to make this work for the person class. So we override it, public Boolean equals, and here's the thing. Because in the object class, the argument over here is of type object, ours must be 2. Okay. So what do we do inside? First thing, we have to check if what we're getting over here, if obj is even an instance of the class person. If it is, then we can proceed. Else, return false right here. Okay. Now, if the object that's being passed here is of type person, is of class, is an instance of person, then we have to compare the data members of the two objects. So we want to compare this dot name with, okay, so I'll simplify this later on. Okay, so if the name variable is equal to object's name variable. Hold on a second. obj, as you can see, name is still italicized. We're doing something wrong. And the thing that we're doing wrong is that obj of type object, of class object, does not have a name member variable, which means we have to do some casting first. Casting, which we studied in last class. So we're going to cast this object. We've already established in the if condition that the object is indeed an instance of person. So we're going to cast this object as a person first. We're going to tell the compiler basically that, hey, this object, it's of class person. And then we're going to access its name member variable. And if the name member variable of this object is equal to the name member variable of the current object for which I'm calling this method, then just going to return true. And if it's not, going to return false. Okay? Now, I can simplify this code. These 4 lines, I can simplify them. Okay? Remember that I'm already doing a comparison in here. This comparison gives me a true or false value. I can just return that true or false value. Return this. That's it. Return the result from comparing this object's name member variable with the name member variable of the person type object instance being passed to this method. Okay, let's go back. Let's try this out again. Okay, so P1 equals P2 should still be false, but P1 equals P3 because they have the same string as member variables. And there you go, it works. False when we compare P1 versus P2, true when we compare P1 versus P3. So please note the comparison between the comparison operator that we just used inside. You use that for comparing primitive data types, so number versus number, so long versus long, integer versus integer, string with string. But if we want to compare all the data members of one object with all the data members of another object, for that we use this equals method, which we really have to write ourselves. Okay, but it is inherited from the object class, and just like the toString method, we override the equals method that we receive from the object class as well. Okay, so this video is already at 23 minutes. I'm going to end this one here, and I'm going to upload a second one on some other topics in a little while.